Hello. The syllabus is right there. All right. Hello. This is Statistics 1. I'm Professor Baker. I'm teaching this class at 4 o'clock and at 7 o'clock on Tuesdays and Thursdays. So if you saw your syllabus and it said 7 o'clock at D219 or you saw D219, that's my 7 o'clock class. I just didn't create two syllabuses. It's the same syllabus. That being said, you do have the option of coming to either class. So if for some reason something comes up and you can't get to the 4 o'clock class, but you can come to my 7 o'clock class, that is totally an acceptable thing. I'm actually going to tell my 7 o'clock class they can come to this class if they want. So there is no issue. You can come to either class and be fine there. The material is going to be exactly the same in both classes. Yes?
Is the 7 o'clock class in the same room?
It's going to be in D219. It's just down a little bit. Yeah. So, you have two main resources for this class. You have the Pearson's MyLab, which you should have gotten an access code for. You do not need the physical textbook. As long as you have the online access, you're going to be fine. That's the more important thing. So in the online access, you're going to see, at some point it'll switch over. You'll have all your assignments there. There's 37 total homework assignments that you need to do on there. From chapters 1 through 10, and chapter 4 is in there too. They're all there. That's where all the grading is going to be done for those assignments. They're all graded online. It's just simple problems. You can do them as many times as you want. All right. It's more of do them. So it's a done or not done. So it's 100 or a 0 on the assignment. It's not like I got 5 right, I get this grade. It's do the assignment, complete it, you'll get full credit for it. The other resource that you're going to have is actually my website. My website has everything else you're going to need. All my class notes are going to be there. All my slides and everything else I do in class is going to be there. The syllabus is there. If you actually go to class blogs, you can see this. So you click on the blog, the class blogs, you click on the statistics, the post for today, and you'll have your the files there, and also the live stream of what I'm doing. So I'm actually live streaming this on YouTube. That's why there's a delay and it's going to bug me, but I will work that part out later. So if for some strange reason you can't come to class, you literally can go to my class and watch it live online and get the exact same thing you're getting in class. The other nice thing about that is that means the class will be recorded and you can watch it later if you want to, or go back and get those resources afterwards. The other thing on my website is the study guides. So I've built the entire class for statistics on the website. So for example, this is today's lesson that we're actually going to go over. So on the website, you'll see a breakdown of each lesson as a one-page website, or one page. So it'd be really quick and easy to see the key points of it, the key information. So you'll have any key definitions that you need there. There'll also be some practice problems at the end of the page there. And on a lot of the ones, not so much the first chapter, but the later chapters, will be all the calculators that you can use to do the calculations. So like when we're looking for standard deviation, I have a calculator for that on my website. So you do not have to actually do that out by hand. We will be using the stat crunch that's in my lab as well, but this is just another resource for you. All right. Syllabus. The main pieces of the syllabus that you need to worry about is, for all intents and purposes, the grading and your the schedule. So at the very end, or towards the middle, actually, because there's a whole bunch of extra pages they have it at the end, you'll see the schedule of what each day is and which class or topics I'm going to be covering. The grading is pretty straightforward. 20% of your grade is the assignments in MATLAB or MyLab. I will be dropping 5 of the assignments. So as long as you do 32 out of the 37, you get full credit. So if there's a couple assignments that you just can't figure out, that takes care of that. You have 3 tests. Each test is worth 15% of your grade. You have a project due, which we'll talk a little bit more about probably next week. That was also up there if you grab that. That's going to be another 15% of your grade. And then the final exam is 20% of your grade for 100 points. Any questions on any of that? Awesome. Now let's get on to statistics. How many of you love math? Okay, there's a few. I'm going to go with the rest of you really don't like math or in general, which is fine. Statistics is not algebra at all. Okay? So if you're one of those ones that's been traumatized by algebra when the teacher's sitting there trying to find X and this whole process down, that's not what statistics is. Statistics is designed to help you look at information in the world around you and figure out what it means. Okay? Statistics is looking at data. And I know numbers sound scary, but in today's world, that's what we're ruled by. Everything you look at is in terms of data. And every decision somebody makes is based on data and based on some statistics. So when you see a pie chart or somebody quoting a statistic or quoting a percentage online, they're quoting statistics. And understanding how they came up with that number and understanding how they calculated it and the process they came up with it helps you understand what they're talking about. I like to say statistics is the only class in math that you can actually lie with. Okay? I can give you the exact same statistic as somebody else, and we can have 2 completely different meanings of that number. Because the number is actually less important in statistics than what the meaning is behind it. Okay? So that's where understanding where they came up with that number and being able to look at the data is so much more important. Next. All right. So we talked about what statistics is. We're collecting data. There's 2 main things or the 2 big ideas in statistics that you look at. We have the population, and we have what's known as a sample. Okay? So those are 2 things we're going to be talking about throughout the entire rest of the semester. Everything we're dealing with is going to be dealing with population and samples. So a population would be everybody. Now, a population doesn't have to be everybody in the world. Okay? Population depends on what you're talking about. So let's say I wanted to figure out what the favorite ice cream is of the students at Three Rivers. Okay? The population would be all the students at Three Rivers. What would be a sample of all the students at Three Rivers?
Nursing majors.
Huh?
Nursing majors.
Nursing majors, yeah. A piece. It could be this class. Like you would technically be a sample of the entire class, of the entire population. Okay? We'll talk about why this class would not be a good sample to use later on. But this class is a sample. So it's just a subset of the entire population. If I wanted to find out the favorite ice cream of the entire of Three Rivers, how hard would it be to ask every single person in Three Rivers? Pretty difficult, right? Okay. You all come at different times, different schedules. You'd have to be here from 7:30 in the morning until probably 9 o'clock at night and all week because every day different people come. So it'd be very difficult to do that. That's where the samples come in. So statistics looks at how we can take that sample or a small group of the population and determine what the entire population thinks. Okay? Looking online and everything else, lots of crazy things are being talked about. And one of the big things that people always are looking at now is they look at the polling data. So like when they ask a bunch of people questions and stuff, and they come out and say, well, they've never asked me. They don't know what I believe. That's true. But they ask a good group of people and a good sample that they can figure that out. And over the years, statistics has proven to be more accurate than actually asking the entire population in some situations. Because, as we all know, people lie. And people won't always give you a factual information. So that can skew or corrupt data. We have the statistic. The statistic is a numerical summary of a sample. So we have two different ones that we're going to look at. And I don't know why this one wasn't on this slide. But a statistic is a numerical representation of a sample, and a parameter. That's on the next slide. There we go. And a parameter is a numerical summary of a population. So just think, the letters go together. Statistic, sample, both S's. Parameter, population, both P's. I know I'm throwing out a ton of words at you. The number one thing you're going to struggle in statistics is not the math. It's the English. Okay? It's literally a ton of words and a ton of definitions at the beginning. Once we actually start using them, a lot more of these are going to make more sense. Okay? But I got to go over the definitions because we're going to see them quite often. And when we start talking about them, you need to understand what they mean. All right. Questions. If you get stuck on something or something I say doesn't make sense or I go too quick for something, ask. Just raise your hand and say something. Because if you're lost, statistically speaking, there's probably a group of people in this room that are also lost. Okay? So don't wait until it snowballs to the point where you have no idea what I'm talking about. Okay? Get the information early. And speaking of that, going to your homework and things like that, don't wait until it says it's due to do it. So like this week we're talking about chapter 1. Do chapter 1's homework this week because it'll make sense. Because next week when I start working on chapter 2, all the definitions and stuff that I'm using here, you're going to need to know. So it builds on itself just like any other math. All right, next two words. Qualitative and quantitative values. All right, what do you think from the word? Now we're talking about this in terms of English. What is the word qualitative? What's the root word of qualitative? Huh? What did you say? Sorry. Colors. Colors are qualitative, but that's not the root word. Yeah. Quality. So colors are a quality. That is a great example of it. So qualitative would be like colors. Give me another quality. Yeah. Shape. Okay. It could be something you like. We were talking about ice cream before. Okay. What are some other qualities of an individual that you might study? Yeah. Yeah. Race, gender. So the demographic information. Okay. So those are all qualities. Now, the other one is quantitative. what would be quantitative? What's the root word of quantitative? Quantity or numbers, right? Yeah. So quantitative ones are typically are numbers. All right. So now give me some examples of a quantitative number. Age. What else? Height. Wait. What else? Your phone number. Is that quantitative or qualitative? Yeah. Why? You can answer, and then I'll tell you guys something.
Because it doesn't, it's not, your phone number is not, while it has numbers in it, those numbers aren't measuring.
Very good. All right, so here's a very easy thing about what I say. When you answer a question, almost all the time I'm going to ask you why. Do not assume you're wrong. I will ask you why if you're right or if you're wrong. The reason why is I want to know what your thinking is behind it. Okay? So the biggest thing with math is it's supposed to teach you how to think about things. It's supposed to give you that logical mindset. So don't think it's bad. And don't stop answering the questions because you don't want to be asked why. But I had somebody the other day that we were looking at simplifying fractions, and they had to get a common denominator. And they said the right number, and then they changed their mind and said another number, and I asked them why. And they couldn't, they had the right answer. They just couldn't explain to me why they got it. And then when we did it, she was like, oh, that is exactly what it is. That's why I want you to explain. Because a lot of times you have a general idea of what the answer is, say it, and then be able to figure out why you're saying it. That helps everybody. That thought process really can help people. You're exactly right. A phone number, while being a number, isn't a number that we're going to do any calculations and stuff with. Right? I can't put all the phone numbers in numerical order. That would make no sense. Okay? I can for height. I can for age. I can for shoe size or things like that. But listing your phone numbers in numerical order or subtracting them doesn't mean anything. So phone number would be quantitative or qualitative. And yes, we like to confuse people in math. That's why those two words are so close to each other that you're constantly going to confuse them. Social Security number is another one. That is, technically, it is a number, but it is a quality, not quantitative. So when you're looking at the differences between qualitative and quantitative, that's the piece that you have to make sense there. So qualitative ones are categorical, and they allow for classification of individuals by some attribute. Where quantitative are typically variables, and they provide the numerical measurements of an individual. And we could typically do some calculations, adding, subtracting, maybe multiplying and dividing. All right. Next two words. Discrete and continuous. Okay. Can a quality be discrete or continuous? Can a color be discrete or continuous? Yeah.
I think something like coloring
All right. So when you think of the word discrete, again, this is thinking about it even just like with English and the typical definition. What do you think the definition of discrete is?
It's not so like you're like doing like favorite colors or favorite like ice cream flavors, you're not really gonna know those.
Okay. Anybody else got a different definition? Yeah.
Like separated or like singular or individual.
Okay. Syllabus is right this one. Okay, so let's think about continuous because these are two words that we're going together, just like qualitative and quantitative, right? So let's see, what do we know about continuous things? Reoccurring.
It's not set.
Yeah. What else?
It's not set, like it could change, like age.
Okay. Let's stick with age, because age is a good one. What would make age continuous and not discrete? Yeah.
It'll like increase consistently.
Are you older than when you walked into this classroom? Yes or no?
Yes.
Yeah. By 20 minutes. But you're still technically older. I know, everybody's like, oh crap, I got older already. That's how long this class has been. So age is continuous because it constantly moves. So time, anything that deals with time is one of those things that is constantly moving. Okay? So that is a very good representation of continuous. All right? Height is another one that's very good with continuous. Can you go from being 3 feet tall to 4 feet tall instantly? No, you have to go through everything between 3 feet and 4 feet to get there, right? So at some point you were 3 feet 1 inch, 3 feet 2 inches, 3 feet 3 inches, and so on and so forth. Okay? So that's continuous. So what would be a good example of something that would be discrete along those same lines that we were talking about with those two things with continuous? What's something that you can jump from one thing to the next thing? Yeah. So you're still going to have, so age and height are still going to be continuous. So you can group them any way you want, but that doesn't change the actual underlying variable. What about dress size? What about dress size? Is that continuous or discrete? Why?
You could go down or go up, or stay the same.
Because you could be like a dress size 30, and then the next time you go and get a dress, you could be 33. It doesn't have to be.
And we can tell that he's a guy that answered that question. You're fine. You're totally fine. I can guarantee you nobody here is buying a dress size that's 33. Normally they're like 16, 14, 20. Pant sizes, on the other hand, 30s and 33s. But what's the difference? Can you buy a dress that's 16 and a half? Can you go to the store and buy a dress that's 16 and a half? No. It's going to be 16 or 18. I don't even think they have a dress size of 17. I think they literally are even numbers once they get that high. So even pant sizes for guys, it's 32, 33, 34, 38. There is no 33 and a half. If you need that, you have to go get it fixed or adjusted. So those are discrete. There's gaps. Okay? Shoe size is another great example. Okay? Shoe size is one of those weird ones because you can get a half shoe size, but you can't go any more discrete than that. So, like, I can't get a shoe size that's 9 3/4. I can get 9, 9.5, or 10. I can't get 9 3/4. So, shoe size is a great example of discrete. So, clothing sizes are great examples. So, when we're looking at discrete and continuous, they both have to be quantitative. They both have to be numerical in nature. Okay? So they can't be colors and things like that because to be discrete or continuous, I have to be able to put them in order. And I have to be able to have that information in a specific order to do that. So these both have to be quantitative values. All right. Questions with that? I know, lots of information first day. These will become easier once you actually start doing them instead of me just talking about them. Oh, yeah. You'll also know that I'm a math teacher because I'm a horrible speller. So if there's things that are spelled wrong on the board, don't yell at me. All right. The next breakdown of values. Nominal, ordinal, interval, or ratio. So these two here, nominal and ordinal, are going to be your qualitative data. Okay? So these are your qualitative data. And these are going to be your quantitative. So, nominal and ordinal, let's look at those two first. What's the root word of ordinal? What is it? I still didn't hear you, I'm sorry.
Ordinary.
Ordinary? Not quite.
Order.
So, ordinal, you have to be able to put them in order. Okay? So these are qualitative data things that we can put in order. So is a phone number ordinal? No. Is your rating on Uber ordinal? Can I sort Uber drivers by their rating? Yes. Okay. So, and is the rating qualitative? Yeah. So, remember, the big difference between qualitative and quantitative is, can I do some calculations with it? Like me subtracting two Uber drivers' ratings doesn't give me anything that makes sense. Okay? But I can put them in order. I can sort them. And that does have some meaning. All right? So ordinal is order. Nominal is everything else. Nominal is basically the lowest level. Everything ends up being nominal. Okay? That means I can't necessarily put them in order. They're data. They're important. So colors fall in there. Phone numbers fall in there. Social security numbers. Things like that. Things that I can't necessarily put in order. It's just data. Okay. And we can collect it and we can make nice graphs and stuff with it if we want, but it's just data. So okay, so basically everything starts off at nominal. If I can put it in order, it becomes ordinal. Now we move up to interval and ratio. And these are probably the hardest two to get correct. But there's actually a really cool thing on my site, and I'm going to show you this now. So it'll switch over in a second. Interval is where the difference matters. So interval, I can have a difference between two things. So I can add them and subtract them and it would make sense. Okay? So, for example, height is a great example of an interval. Okay? I can say you're 3 feet taller than somebody else or 2 feet taller than somebody else. Okay? I can subtract your heights and that has some meaning. I can subtract your ages and that would have some meaning. Okay? I can, let's see, something else. They did temperature. I can say somebody is, or something is 20 degrees warmer today or 20 degrees colder today. All right? I would say it's colder today than yesterday. Actually, I think it's a little warmer the day than it is today. But both days have been very cold. And it's not going to get warmer anytime soon. So those are intervals. So intervals are things where the difference matters. There also isn't a zero. So like zero, like I have zero in temperature, but zero doesn't necessarily have a meaning other than that piece. It's just another value in there. All right. Ratio, zero has meaning. Zero means nothing. Okay. But the other thing is I can multiply or divide it. So I can say I have twice as much money as you. That has meaning. I can say I'm twice as tall as you. That has meaning. Can I say, and you can look at it on the screen, I can't say you're twice as hot. So temperature is one of those weird ones that catches people a lot. All right? And the reason why I can't say twice as hot isn't necessarily a reason that most people would think of. It's because of the units. So if it's 40 degrees out today and tomorrow it's 80 degrees, it's twice as hot in Fahrenheit, right? But in Celsius, it's not. So your units would matter in that situation. If I say I'm twice as tall as you in feet, I'm also twice as tall as you in meters. Okay? The calculation still works, even though the units change. So as long as if the units change and the calculation still works, then it's ratio. If the calculation doesn't work anymore, then it's not ratio, which I know is going to make things hard. But that's really the distinct difference in that. And that's one of those ones, so like one of the things that the book does is it'll give you some value, and they'll give you some things to try. So like, for example, there. And they always seem to ask for temperature. So let's do some. Race. Which one of those four do you think race is? I'll go back to them. Nominal, ordinal, interval, or ratio. Oh, it's there. Never mind. I'll make some up in a second. Hold on. I will make some up. I have a book. Nation of origin. Nominal, ordinal, interval, or ratio. Where you were born. Which one of those four?
Nominal.
Why?
Because you can't put that in order.
There you go. That's it. You're done. So the nice thing is, this is like a pyramid. Ratios at the top, interval, then ordinal, nominals at the bottom. So as soon as you hit one that you can't do, you're done. So if I can't put it in order, I'm done. It's nominal. You don't even have to go any further. Okay? But a ratio, I could put in order, I could do the interval, and I can do the ratio. So you want to pick, they ask you for the best one. You want to pick the highest level of measurement. That's the highest level in the pyramid. Year of birth of a college student. What is it? Ordinal. I can put them in order. Yep. Is that the best one, though? See, that's the thing. It's going to fit in multiple categories. You want to find the highest. So what's the next one after ordinal? Interval. Can I subtract two people's birth years and get some information that means something? Yes. So interval. Can I divide them and have meaning? No. Okay. So interval is the highest I can go. So that would be interval. Highest degree earned. Okay. So highest degree earned, is it going to be qualitative or quantitative? Qualitative. So I can't go any higher than ordinal. So I know I'm done. It's words. I can't do any calculations with those. Okay. The value of your house. Why?
I saw it on the notes, so I wrote down where it said height and money.
Yes. Anything with the money, because you can do calculations. Okay. And money is, so the difference, like when you convert between units, the why temperature is that outlier is because it's not just the ratio, you're adding to it. So like to convert from Fahrenheit to Celsius, you multiply it by something and then you either add or subtract 32. So there's an extra piece in there. That's what screws that up. Like when we're talking about money, if we're talking about US money or euros or Canadian dollar, anything else like that, there's a multiplication to it, but nothing else. So the ratio still holds true. So it's really temperature that is the one that throws people off in that respect. Ooh, one other one that's going to come up a couple times. Money. Is it discrete or continuous? Why? Okay. So money is the weird one because it has decimals, right? I get $3.22. Okay. Normally when people think continuous, if it has a decimal, it's continuous. If it doesn't, if it's a whole number, it's discrete. That tends to be the dip. But I can't have a half a cent. So while it's more continuous than something else, it has an end. Continuous means everything. Okay, so that you kind of have to think back to the math and the number line where you go between everything, and I can keep breaking it down further and further. Money, I can't. There's a point where I'd have to stop. So money is discrete. That one does come up quite often. So, all right. So you picked up one of the things that you were supposed to pick up. Talk about this briefly. Is your project. Okay, so in April, there's a week that I'm going away, so I won't be here. So those 2 classes are going to be your time to work with the group or on your own to do the project. Do not wait till April to start this, because you have to collect some data. So as part of this project, you're going to have to decide what you want to study and how you're going to start collecting that information. Okay? So the next section what we're going to look at I was going to start talking about is observational studies versus designed experiments. Those are really the 2 main things that you're going to look at for research. You guys are not doing designed experiments. Designed experiment would be you're going to have control groups and placebo, things like that. Most of your medical research and stuff like that goes into designed experiments. You're most likely going to be doing more of the observational studies, collecting data, doing like surveys and things like that to get some information. So there isn't anything wrong with either one, but they give you different types of information what you can do with it afterwards. So the first thing you want to start thinking about in your project is, what would you like to know? Like, it can be anything. Like this one, like there's big things like this one, looking at cell phones and brain tumors. Like there's a lot of research around because before you'd hold your cell phone to your head and there'd be radiation and stuff there. Now you just stick Bluetooth headphones in your ears and you have the same problem because Bluetooth is still technically a radiation. But there's lots of research around it to show that it really isn't nearly as dangerous as we would think it is. Those are designed experiments. They actually they studied people and those type of things. So you're not going to do something this big, but there's things you might want to know. So start thinking about that. Come up with what you think you want to do, and then send me an email and let me know what you're thinking. Yes? How big what? You can group up with 2 other people. So it can be a max group of 3. Okay? You can have a max group of 3 people. Yeah, you and 2 other people in the class if you want to do it. You are more than welcome to do it completely yourself. You do not have to group up. If you'd like to group up, you're more than welcome to. Okay? I will expect if you're grouping up, you're collecting more information. You're going to do some more like that type of stuff. So don't group up and say, oh, this way it's going to be less work. It's like I'm going to expect a little bit more work from the people who are grouping up because you have more people to collect data and do that type of analysis and those type of things. So just keep that in mind. All right. So if you are going to group up, let me know that and let me know what you're thinking about studying. Because this way I can give you some feedback. Like, you might want to think about something else that's going to be a little too big, or how are you going to start collecting that data? We can start having those conversations before you get too far along in your project. All right, so what's the difference between an observational study and a designed experiment? An observational study measures the value of a variable without attempting to influence the variable. So that's the biggest difference. So you're going to collect some information, but you're not going to try to influence the outcome. Okay? So in a design experiment, you are intentionally manipulating some of the information or the values to see if there is an actual response. Okay? So let's think back to that horrible time 5 years ago of COVID. Because there was so much research out there, it just became a lot easier to understand what was going on. If I wanted to determine if a mask stopped the virus, okay, the research studies that they did were all observational. They would study people and say, okay, this group of people here wore masks, they got this. This group of people didn't wear masks, that was there. The designed experiment would be, they would take this half of the classroom and put you in masks, that half of the classroom and tell you couldn't wear masks, and infect you all, and see how many of that side got infected compared to this side. That's a designed experiment. I'm influencing the thing. I'm specifically saying this group is doing something and this group is not, so I can see what the effect is on it. Okay? You see that all the time in medical research. Placebos are done. You have the control groups. Those are designed experiments. I'm taking a group of people, I'm giving them this medication to try to see if it's going to actually have some kind of an impact on it. A lot of studies, though, are observational. Say it was actually a situation out in, I think it was in California, where they noticed that certain schools had a higher rate of cancers appearing in young kids, like leukemias and things like that. And they were trying to figure out why. Now, it wasn't like the entire school had leukemia. It was like, but when we're talking about clusters, we're talking about this group of people had a higher rate than the general population. And they noticed this was coming up, and they were trying to figure out why. What they found is the material that they used to create the playgrounds were contaminated. So this company was taking a bunch of industrial waste and everything else like that, reprocessing it into what they thought was an inert, like gravel and like asphalt type mixture to put down. Well, come to find out it wasn't. But that was an observational study. They noticed something was going on, and then they looked back through the data to figure out why that was happening. That's an observational study. Does those two different things make sense? Okay, they weren't infecting the kids; they were putting them in danger. It was there, and they were looking at it. That's actually how they do most types of cancer clusters. They do it a lot of times with asthma and stuff too, looking at like why is certain cities and things like that will have a higher asthma rate than others, and they determine a lot of it has to do with air quality, or it could be pollution from plant like energy plants and stuff like that. So Hartford had a big issue where we had a waste or trash to energy plant that was spewing out smoke and everything else, which was causing a higher rate of asthma in Hartford than in West Hartford that was literally right next door. So that's the difference between an observational study and a designed experiment. All right. I wanted to do a study to determine if the COVID vaccine was good. That actually worked. Okay, so now we're in December of 2020, and I'm doing these studies to determine if my new COVID vaccine is going to actually protect the population. Now, a lot of you guys were young. Some weren't, but a lot of you were young. So when the original studies came out, they said that the COVID vaccine was, I think they said between 90 and 95% effective in preventing COVID. When they started putting it out to the entire population, it turned out to be closer to 70% effective. Okay? Now, when they were doing these, they were designed experiments, which means they gave certain people the vaccine and they gave other people a placebo or a control. So they didn't know if they were getting the vaccine or not. And then they just they looked, said, okay, are these people getting infected or not infected? Okay? What are some things that could influence how effective something is if we're thinking about COVID? What are some other things that we did during COVID that we don't do anymore, thankfully? Yes. We were socially distancing. What else? Masks. Staying home. Okay? So, yeah, staying further away from people. All right, so if all the people in this study, do you think somebody would apply and volunteer to take the study if they didn't really care about COVID? So the people who didn't really care, that weren't social distancing, that really weren't wearing masks, do you think they were running out to join a study for the COVID vaccine? No. So everybody that was signing up for these studies, for the most part, were people who were social distancing, wearing masks, staying away from people, right? So they were already at a lesser risk of getting infected to begin with. So add in the COVID vaccine, and you're going to have a higher rate of not getting infected because you're already doing all the other things that you're supposed to be doing. Those are known as confounding variables. Okay, so confounding variables are ones that have a relationship to what it is and can impact the outcome. The other one is a lurking variable, which is also, again, things that were not considered but can affect it. So these are things you need to look for. So if we're asking people their favorite ice cream, you're going to get a lot of people who will say chocolate or vanilla and things like that because that's all they've been exposed to. They might not be eating the more decadent ones like Rocky Road and buttered pecan and things like that. So looking at why things are there or other variables or other things that can impact your research is important. And that's where those things come into play. Almost done, I swear. So, some lurking variables in flu studies: age, health status. You're more likely to catch the flu if you're older, if you have other health situations. For seniors, mobility is a big thing. If you're not moving around, you're sitting in one place, you have a tendency to get sicker. All right. This is the big one. Observational studies do not allow us to determine causation. Only association. What's causation? Yeah. Right. So if we're looking at the difference between an observational study and a designed experiment, why can't I claim causation if I'm just studying what's happening? Yeah.
Because you're not like values, you can't tell it. You control it.
Right. You need that manipulation. All right? You need that break. You need that control over it to say, okay, I've controlled everything I need to. This is the only thing that changes. So I can say this caused this outcome. If I'm just looking at a bunch of information and I'm not controlling that, I can say there is an association, there is some connection, but not necessarily a causation to it. There are 2 or 3 types of observational studies we can do. Cross-sectional studies. So cross-sectional studies are where I collect information about individuals at a specific point in time. For most of you, that's what you're going to do. Okay? You're going to collect a bunch of information right then and there from a bunch of different people and use that to determine something. Case control studies means I look at you now and I look at your information 6 years ago and I look at your information 12 years ago, so another 6 years before that, and I look at things that have changed. So case control studies, you look back in time to see how it has changed in that individual over time. So you need more information. That's why it's a case. You're looking at that person over time, or a group of people over time. The last one is a cohort study. So cohorts are different than a case study because you're not looking back, you're looking forward. So a cohort study would be, I would take all you guys right now, I'm going to say, this is going to be my cohort, and I'm going to follow you in all of your math classes going forward and seeing how this class impacted your ability to do math going forward. Okay, that would be a cohort study. I would look at one group of people over time and collect that information. This one's perspective because I'm looking in the future, where the other one was retrospective because I was looking backwards. Case study means I already have the information, which makes my life easier. A cohort study means I need to collect that information over time. What's a census? Yeah.
It's like data collection.
The big piece of a census, the main part of it, is it's collecting the data for the entire population. So like in the United States, every 10 years, we have a census. They send those forms out to every single person to fill out for your household and send it back. If you don't send it back, they send somebody to your house to collect the data. And they will keep sending somebody to your house to collect the data until they collect the data. Okay? Because there's so many other things that go into play with that census and why it's important for us to have that accurate representation of our population. But a census can be anything. The college can do a census for all the college students and determine where they're going forward in their career choices and things like that. So it doesn't necessarily have to be an entire population of a country. It can be anything that you're collecting. But you're collecting it for everybody in that population. So now let's think about this. A census will collect all the data for an entire population. How much money do you think it costs the U.S. government to do the census every 10 years? Ballpark. Yeah.
2 or 3 million?
How many people are in the United States? Huh? Yeah, about 350, 360 million. Okay? How much do you think it costs to ask one person a bunch of questions? So it's going to be at least $1. So now we're at least 350 million. It's actually closer to between 10 and 20 billion dollars. It costs us to do a census in the United States every 10 years. Which, based on our budget, is basically nothing, but it's still a lot of money. So a census is very hard to do because it costs a lot of money to do it. There's actually a push from a lot of people to say, let's get rid of the census and actually go to what's a statistical analysis where we only look at samples and pick people that way. So the question then comes in is back to that initial statement I made at the beginning of class. Well, they never ask me the questions. So I'm not represented in that data. So how do they determine who they pick to ask questions to? How many of you answer the phone call for somebody who does a phone number that you don't know? Anybody? Okay. How many of you have ever answered an online survey by phone? Carolyn, don't get mad at me for this one. Who do you think, honestly, is the ones who are answering all those questions from online phone surveys? Old white people. Because they're sitting at home, have nothing better to do. The phone rings, they answer it and answer a bunch of questions. Okay? Your generation is the least represented group in any of those surveys. Because you don't answer the phone. And the only way they can get a hold of you to ask you these questions is to call you. I could put out a survey online, but I don't control who answers it. And that's important. Okay? So, the last thing we're going to talk about today is what's known as random sampling. If I put out a poll right now on the internet and I said, all right, let's think something non-controversial so I don't get in trouble on the first day of class. Who is your favorite Disney character? Mickey Mouse or Pluto? Who is most likely to answer this survey? Yeah.
Disney things?
Yeah. So am I going to get a good representation of who everybody in the United States likes? No. I'm going to get Disney fans. Okay? Or if I put out a survey, do you like Star Trek or Star Wars? The fanboys are going to hit it. And they're going to share it out. And one's going to pop way up. But it's not a good representation of what's going on. That's why internet surveys are great, but you have to understand that they're not statistically valid. A great example was in 2020 for the election. So most people only know two people who are running. There's actually, on any given time running for president, there's like hundreds of people that run for president every 4 years. I think the 2016 election, there was 6,500 people that had registered, that had filled out the paper to run for president of the United States. 6,500 people. Not two. But there's typically four major candidates that are actually running at any given time. Republicans, Democrats, Libertarians, and Green. Those are the four people who are typically on all the ballots across the country. So a poll came out in 2016. It was, who are you voting for? Well, it got shared around a whole bunch of libertarian groups, and it had, I can't remember who was running it that week. I can't remember who was running that one. But the libertarian candidate had blown it out of the water. It was like, they're going to win the election. We know that's not true. But that was where it was getting shared, so that's who were voting in that poll. So it wasn't an accurate representation of the entire country. So how do you sample that? A simple random sample is one way. And that's why I say phone numbers are important. Because what they do is they have all your phone numbers in a database. Everybody's phone number is in a database. It's not attached to your name, but it's in a database. And they have a computer program that goes through and randomly selects a phone number. And that's what the computer calls that phone number. So a person sitting there, I'm doing the pollsters, I have my headset on, I press the button, say call somebody. The computer randomly picks a phone number and calls them. That's simple random sampling. You do that and get 2,000 people across the country to answer your survey, I can determine what the entire country thinks. Okay? But you guys don't answer the phone. So your data is not included. And that's where some of the problems start coming in. That's why, since I would say 2016, honestly. 2012 wasn't too bad. But a lot of the polls around election times have been wrong because it's not hitting the vast majority of the population. Okay? So, moral of the story, answer your phone and talk to some pollsters. Get your views and your input out there because all the politicians in Washington look at those polls. Okay? I know it sucks to answer the phone and you don't know who's calling, but sometimes it could be important and give you good information. All right, we're done for the day. Questions? Make sure you get logged into the Pearson online program. If you don't have your code yet, there is an option down the bottom to click for 14 days to get in before you get your code. You have to be logged in there doing work. Do not wait until the first day of the first test, which is February 19th.